Welcome everybody. Today I'm going to try to do something kind of fun, hopefully. I'm going to follow along this fantastic video by Dave Crabb showing an example of composition versus inheritance. What he basically does is he puts together a little project and he breaks inheritance and then he fixes it using composition, and I thought it was pretty neat. So what I'm going to try to do is reproduce the steps that he does, but on this pre 1.0 bleeding edge assembly compiler. And that's the goal of the day. So what I have here to start out is a project template. This is my standard console window template. All it does is pop up the console window and press enter, and I hit the enter key and it disappears. So this is my template I use for everything. Down there is my function main that we'll be putting some code in today. So in the video I have to make I have to make a couple class objects. Cat.asm. Now I just call it a class object, but actually I also call it a module, and sometimes I call it a namespace. Sometimes I call it a class module. It's all basically the same thing, but with variations sometimes. So this is going to be the cat, and it's going to have some code. It's going to have a function that says meow, and we're going to invoke console.code.writeLine meow. Okay. The next class module we're going to create is going to be a dog. And the dog is going to have code and a function that says bark. It's going to be invoke code.writeLine woof. Okay, looks like my IntelliSense doesn't want to disappear. Isn't that nice? Okay, so we're gonna go. We got 3 open here. Here's our entry point. What we're going to do is we're going to say local indata cat named Garfield. Okay, I'm not going to get into too much detail on what this is exactly. Well, maybe I will, I guess. The indata is instance data. And what it's going to do is it's going to be instance data that's part of this module. The fact that it's local means that only this function will be able to use it. Cat is the class object slash module. Named does nothing except make this look like more of a sentence, and Garfield's the name of the variable. Now I'm going to say invoke Garfield.meow. Let's add another local. Instance data dog named Snoopy. I'm going to invoke Snoopy.bark. Okay. Let's compile that. And let's run it. We have a meow and woof. Okay. That was the first part of the video. Now I'm going to pause this video here and watch Dave's second part of his video, and I'll be back. Okay, I'm at 5 minutes and 41 seconds on Dave's video, and then I stopped it. So what he does is he wants to have both the cat and dog be able to have a function called eat. And he doesn't want to do duplication of code, so he creates what's called a base class called animal. And we're going to do that right now. Animal.awesome. And this class has code and a function called eat. And console.code.line yum. So we get to write the function once, and two different objects get to use it. That's the goal here. So let's go over to the dog. Still has the IntelliSense up. Isn't that funny? What we're going to do is we're going to make some instance data for this module. And we're going to make it private. We're going to make an animal named myAnimal. And then we're going to do a special define statement, myAnimal.eat as eat. So now the dog will have a function called eat. And likewise on the cat. We're going to do the same thing. We're going to make some indata. We make a private animal named myAnimal. We're going to define myAnimal.eat as eat. Okay. Now we'll go to the main entry point. And back to Garfield, and he now has eat on his IntelliSense drop down, and we'll go to Snoopy. He has eat on his IntelliSense. We're going to compile. And run. We got meow, yum, woof, yum. There we go. I'm going to go ahead and pause it and watch the next part of the video. Okay, now I'm up to 6 minutes and 31 seconds of Dave's video. He makes a few more objects, a cook robot and a clean robot. There's cook robot. And the cook robot has a function called cook. There's that IntelliSense that doesn't want to disappear. Every video I make has a new feature. It's always one step forward and two steps back. Or I mean, 2 steps forward, 1 step back. Let's see where we're at. We're going to make a cook robot. Like he says, I make homemade pasta. Okay, there's the cook robot. Now the next one is going to be a clean robot. And function clean, invoke I vacuum dust. Okay. Then we'll go back here and let's just comment out dogs and cats. And let's make a robot. He makes a clean robot named my robot. Invoke my robot dot clean. I vacuum dust. Okay, let's go watch some more video and we'll keep going. Okay, I'm up to 8 minutes 11 seconds in the video. What he's done is he's created a new, what we're going to call like a base class of the robots. He called it robot. And the robot can do a function called move. I believe he says mobility. It comes over here to the main one, and we're going to comment out those lines. I'm going to make a new local. It's going to be oh, I forgot a step. Yes, I did. Unless I want Rosie to be a capital R because it's a name. So I'm not going to finish this because I forgot a step. We need to go to our cook robot. And we need to declare some in data. It's going to be a private robot named my robot. Named. Now we're going to define my robot move as move. So this will give the cook robot the ability to move. And likewise, we want to come here to the clean robot. Oops, make some in data. Do the same thing. Private robot named my robot. Define my robot dot move as move. Okay, now let's go back to the program. Now we got Rosie here, and I want to invoke Rosie dot cook. Invoke Rosie dot move. Let's compile it. Let's run it. And there's the cook and the move function. Onward and upward. Fantastic. Okay, the last stretch of the video is making a super bot. It's a robot that can move, bark, clean, and play games. So, here we go. Let's give this a shot. We're going to make a super bot module class, namespace, whatever you want to call it. It's going to have some in data. It's going to have, let's see, to move it needs the robot. To bark it's going to need the dog. Named my dog. To clean, it's going to need the clean robot named clean robot. And what's interesting is that my clean robot also can move. So I think I'm going to take this one out. And yeah, so let's do the defines. There's the bark. Let's do my clean robot dot clean as clean robot dot move. Let's move. And the last one is play games, which we don't have a function for that yet. We'll just add that to the superbot. Play game. Invoke. I like to play chess. Alrighty, I think that looks good. Let's go back here. I'm going to comment out this and this. Try it again. Now we're going to make a local superbot named, he called him Henry. Let's get that right. And there's Henry, can bark, move, clean, oops, play game. Alright, let's give that a shot. Woof, bark, move, clean, play games. Fantastic. I'm just going to watch the end of the video here real quick. Okay, that's the end of the video. So that was kind of fun. I did notice something that I'd like to point out here. Something kind of cool, actually. So on this last example, I'm going to comment out bark, clean, Henry.move. Henry.move comes from the robot module. And I'm going to put a no up there. The move is just a function that is in the robot module. And I can run that function without using any OOP. Okay, so that's kind of maybe a different concept. Normally in other compilers you have to, make an object first, but these like I said, these are classes and modules kind of together. So they kind of got 1 foot in both entries in both rooms. So you can run these functions without making instantiating them, which, obviously you're gonna have a question about how is that possible, but I'm just gonna, for now, I'm just gonna say that because this is kind of cool what I'm gonna do here. So what I'm looking for here is I want to see, and we're going to go to the assembly and the debugger and look at how much lines of assembly it takes for Henry to move versus a robot to move. So the robot to move would be very, very small, calling a function. But Henry is a super bot that is in OOP, and it's encapsulated, and it's a base class, and so the there's layers of abstraction that go from superbot to robot, and or a layer of abstraction. So I'll be curious to see what is the overhead of such a thing. So let's create it. First, let's just go ahead and run it. So that doesn't tell you much. They both ran the same function. But now I'm going to go to the debugger. We're going to look at what the lines of assembly looks like. Okay, I've run a few lines here. I'm going to run the line. I'm on the line now where you open the console window. There's that. I'm going to drag that off the screen. And this is going to be the function called main. We go into that, and there is this call. This is Henry calling the move function, and this is just the bare bones move function calling the move function. And you can see the move function got called twice. But what's really kind of cool here is that it's the same thing. It's the same line of code. There is literally no overhead for the OOP abstraction. It reduced to just one function call, which is kind of cool. I should have known that was going to happen, but I just wasn't thinking about it. I have to admit that this compiler could not do this project when I started. The define statement I don't believe existed, or needed to be upgraded a little bit, and I had bugs and things, and I had to work through some things, and I got rid of the static keyword everywhere, and that kind of created a little ripple effect I had to work through. And the way objects are declared, I changed that. I don't know if anyone was paying attention to my last video. I had a keyword called join. Well, I got rid of join, and I made what join is to be the default behavior for when you declare an object. Let's go back there for a second. So I think my video was for the zero overhead string object where I used the word join. Well, this word join would be in here as well, because it's basically doing the same thing as a join. What a join is it combines Henry's data, or the superbot data, with the module we're typing into it. It just combines it. Whereas before, it was making a pointer, and the pointer would default to be a null pointer, and you'd have to instantiate the object using a function, and it's kind of a longer process. This seems to be so much easier, and until this breaks, I'm going to keep doing it this way. It just combines the objects together. It's kind of like bundling. So the superbot object is kind of bundled with this module, and it's actually kind of like let's say you typed in X, Y, and Z, just regular variables. They would be their data would be in the module you type it into. You wouldn't get a pointer to the X variable, and you wouldn't get a pointer to the Y variable. So literally what I'm doing is I'm putting object data in, combining it in. It's obviously more than one variable. It's a struct. So it's just combining them together the same way, and it actually kind of works really well, amazingly. So if you made it to here, thanks for watching. I guess that's all I got for today. See ya.